As we begin to think about atomic theory, one of the things that I have our students do in class is take a sheet of paper, a really small part of that sheet of paper, and then keep ripping it in half and ripping it in half and ripping it in half. And if you think about it, if you keep ripping it, you can get it to be where it's really small, but then even your fingers can't rip it, right? So maybe you could get some tweezers or something like that and keep ripping it. And so if you think about, what makes up everyday objects. It's we could just think about, okay, yeah, if we just keep ripping and ripping, we'll just get this little, maybe small little blob that makes up matter, eventually, right? Maybe we can't even see the size of it. And so if we understand the history of matter that way, in the beginnings of that, we could see why, at the beginning we had very, very basic understanding, and then through the years, kind of developed the atomic theory. And so 400 BC, the Greek philosopher Democritus, probably butchered that name, proposed that matter is made up of atoms and cannot be divided. So, if you get down to the very, very basic elements, didn't even use that word, but that we have these very small building blocks. And then really up until the 17th century, his theory remained unproven. Experimental sciences weren't popular yet in terms of looking at this. And Newton believed all matter was ultimately made of the same thing, that everything that we see on Earth, ultimately had the same building block there. And it wasn't until the 19th century with Dalton, who was a chemist, suggested that atoms were different and had different properties. He used chemical reactions proving his ideas and showing that, there's different elements, there's different building blocks, that the atoms aren't all the same thing. And then, continuing with early atomic theory, matter is made of particles and it contains charge, and there's electrical properties in matter, but the atom itself is neutral. And so J.J. Thompson, 1879, discovered the electron, and his discovery provided a new model of the atom. And so he used the cathode ray tube, and it's really interesting how this works. There's a picture of this here. Let's use another color here. A picture of it here, and as he set this up, he actually was able to get those electrons to fly off one side and go to the other, and was able to measure that electrons have charge, that they have a certain amount of mass, and was able to say, okay, we have these electrons that can go from atom to atom. And so we can shoot those electrons from one side to the other, and electrons weren't even known at that time until he found this out, and he took the mass of the cathode ray itself and discovered that electrons themselves actually had mass. And this is very, very significant. So his model is the plum pudding model, and you've probably seen this before. Electrons floating in a blob of positively charged material. The reason they call it plum pudding is because they, I guess, had pudding, and inside the pudding they had plums, and so the analogy here is that these electrons are plums inside a positively charged pudding, and the whole pudding is positively charged, and then you have these little electrons that are like plums that are floating around, and can go from one plum to the other, or one pudding to another, and and so, and intuitively that kind of makes sense, right? If you keep splitting that sheet of paper we just talked about, then you eventually get a blob. And so that kind of, intuitively makes sense. We know that's wrong now, but, at the time it definitely made sense.